This is really weird. I'm looking at my... Okay, maybe I need to boost this volume up a bit. Give me 2 seconds. Filters, how do I boost? Gain... 3? Is that it? Maybe that does it. That still looks a bit low. I don't know, maybe it needs to be a bit higher. No, 8's too high. 6. Okay, maybe I'll just have to talk a bit louder and clearer. Alright, well anyway, the reason I'm doing this is because my microphone seems to be canceling out a lot more of the ambient noise. It just, whenever I'm not talking, the bar is at 0, which it's never been before, which is cool. But anyway, let's go ahead and get started. So today, we are going to be looking at, I'm going to turn this music down a bit. We're going to be looking at the client side of Winsock programming today. So last time we looked at the server side, and I made a few changes there. If I can just pull it up. So the only thing I pretty much did was I kind of just changed how it declined clients when there was when it was full. So if it was full, we would send the overflow message first and then shut down the client. And then otherwise we would scan through the list and add it otherwise, because no matter what it was, no matter if we were full or not, it was sending the welcome message, which we did not want to happen if we were full. So that happened there, and I think that was pretty much the only change. And then also, if the welcome message failed, then I also just removed it from the array, just so it could be consistent with our array construction. Alright, so yeah, let's go ahead and create a new folder. I already put it. It was 29.2 as the client. And I'm going to have 3 batch files here. So the reason why is because if I want to connect multiple clients, I can't be building and writing to the same executable. So we'll have one build. We'll have one command file for the build, and that will just be the gcc main.c-o client, and then we link the library as ws232, and then that's the build, good and good. And then the run will just be client, then pause, then cls, the second half, and then start will just be build and then run, just like that. Alright, so let's go ahead and create our main.c, and we're going to go ahead and have some includes here. So include stdio.h, and we'll do our hello world today. So if I go ahead and do build, then it will build the executable, create client.exe, and then if I do run, it'll print everything out. And then if I do run, it'll build, but if I do start, start I guess opens up a command prompt, so we can't use that as a command, but start will build and then run, but I guess I can't do that. Who knows? Alright, either way, we can just combine them, it's fine. So start will just be this, and then everything in run. Simple stuff. Hello world, perfect. Alright, so let's get out of there, and let's go into main.c. So I will have the server code on the side here, just so I can draw some parallels, but it'll be very off to the side. Alright, so the first line of this is going to be the same thing that we have above, or on the server side. It's going to be if not defined, win32, lean and mean. Then we're going to define it, the macro. Once again, this will only this tells us, or tells the compiler when we include Windows. So we're going to do that right now. Include windows.h. This will tell the compiler to only include a certain amount of like a very, like the necessary files. So we'll have Windows included. We're also going to want to include Winsock 2. So include winsock2.h. Then include ws2 tcp/ip.h. And then we can also include iph, the other one that we had. So pretty much these are all the same includes. So lines 1 to 9 are the exact same as the server. But we're also going to have two new includes. It's going to be include process.h, or you know what, we'll do that later. And then once again we have to link the library manually. So we'll do a hashtag pragma comment, and it'll be a lib comma then ws2 underscore 32.lib, like that. Alright, and then we'll have some macros as well. So we'll do hashtag define bufflen as 512, hashtag define port as 27015, and then hashtag define address as 127.0.0.1 as for localhost. So that's just the port and the address of the server that we want to connect to. So pretty much 1 through 15 now is the exact same as the server. So we have the same includes, and then the same macros and the same library linkage. All right. So let's go into the main method now. So we have this. All right, and then we're going to declare the same thing up here. So we'll have an int result. That'll be the same variable. And then I'm going to actually outline the sections now, and then we will write the code. So we'll start with the initialization once again. I just want to keep this consistent. Let's call them 50. Right? So we have the initialization, which is where we will, it's simply where we're just going to set up WSA. Then we're going to set up the client socket. So we're going to construct the socket, bind it to the address, and then we will connect it to the server. Then we will have our main loop. Now the main loop is going to be a little weird here because we're going to want to do two things. We're going to want to send and receive. We could implement this with the server as well, but I just wanted to skip that because the server video was going on a bit long. But I'll do that next time, or in another video maybe. But we're going to have to handle two loops simultaneously. So we're going to want to be kind of taking in input from the console, which will be skewed through scanf, but we're also going to want to receive messages from the server using the rest function, which are both functions that will loop until we get something. So if we want to do that simultaneously, we're going to actually have to start using some threading, which we will look at when we get to the main loop. And then after the main loop, we can simply go through a cleanup as we did with the server. All right, so initialization. Same exact stuff that we've seen before. So it's going to be this exact stuff right up here, or right up here. No, right here. So we're going to have our WSA data, Then we're going to say result is equal to WSA startup. Oops. We're going to make a word, version 2.2, and store the result in WSA data. Then if res, so a non-zero value, then we're going to say printf startup failed with error results. And then just return one. Alright, so that's initialization. Now we're going to set up the client socket. So we have initialized Winsock. This is that's once again WSA is just the Winsock API, which gives us all the socket libraries and such. Alright, so for our socket, we're going to set up the socket itself first. So we'll have socket clients. Clients is equal to sockets. The family is going to be AF inets. The type will be sock stream, and then the protocol will be IP proto TCP. So this is the exact same as the listener, and we're going to have the same check. So we can actually just use the same exact language here. So if client is equal to invalid socket, then printf error with construction. I just want to use the same language that we did. So and this will print out the integer from WSA get last error. And then we have to do WSA cleanup, since we have initialized Winsock, so we need to clean it up and then return one. Alright, so we've created the socket. Now we need to bind it. So this is the construction. Now we need to not bind it, sorry, we need to connect to the address. So let's set up the address. So we'll have a struct sock address in. This code is going to be the exact same. So the address structure here, then we're going to say address.syn address.s address is equal to inets underscore addr. So we're going to go from an inet string to an address value, and the string value will be address. Yeah. We also want to set up the family, so addr.syn family is equal to af inets. That once again that's IPv4. And then for the port, we're going to say address.syn port is equal to H2NS. So host to network short of port. And then we're going to connect it. So we're going to say result is equal to connect. We're going to connect the client socket to the struct sock address pointer conversion of the reference of addr, or of address. So once again, these arguments are going to be the exact same as bind for the server. So we're just converting the pointer of address, and then we're going to get the size of the address. And then if If res is equal to socket error, then we're going to pretty much we can do the exact same. So I'm just going to copy it because this is error checking, so it doesn't really matter too much. And then we also have another error if the client is equal to invalid socket. Then it's gonna be the same stuff. But this time we don't close the socket because it's an invalid socket, so we can't really close it. Alright, now for our main loop. So let's think about it. Let's think about what we have to do. We have to I talked about this a bit earlier, but we're going to have to send messages from whatever method we want. It's going to have to involve a loop because it's going to be a sustained connection. So that's going to be an infinite loop until we get some string from the console per se. So we're going to be using scanf. So yeah, scanf, but we can also use some other generation from UI that could be integrated in several different ways. We're going to be looking at how to kind of allow the customization on that front, because if we use a thread, we can kind of customize the function that we pass into threads. So the thread can be told to run on a certain function, but we don't have to define that function in this file. We could put it in another file, but for our sake we are going to. But if we wanted to say put this into like a structure, put the client into a structure, we could definitely do that, and just change the function that the thread runs on, so where it could take it from a different channel. And then we also have the receive loop, which is just going to be pretty much the same or similar to this, this server's main loop, except we're only going to be looking at this right here. So we're only going to be getting a message each iteration. So there'll be that. So we're going to have to integrate these two, and then we'll be done using multi-threading, since these functions cannot simultaneously run, because they can only run, I forget what the word is, I don't know why. They can only run sequentially, that's it. Alright, so we're going to be using the threading library. And on Windows, and we're going to be using Windows since this is Winsock, so it just lends itself. We're going to be including process.h. This has all of the header files, or all the structures for the threading. Now for our thread, we are going to start by creating the function that we will use. So I'm going to go above main, and I'll create our signature. So it's going to be a return type of dword. So dword is in the Windows SDK, and it's just a long. I believe it's 4 bytes or 8 bytes. I forget what. I could just look that up actually. GDB. Yeah, that's not going to work. Let me just print this out actually. didn't like it. Why not? Why does run? Oh, because I want. Oh, I'm an idiot. What? What is going on? Oh, I didn't save it. I'm okay. My brain is shooting itself right now. Print F, dumbass. All right, size is 4, so yeah, it's a word, which is 4 bytes. So yeah, that's like a standard way just to store a word on the computer. All right, so the signature is going to be return type dword. Then we're going to have this attribute here, WinAPI, to denote that it's going to be in the using the Windows API when we call this function, which is required for the multi-threading. Then we're going to say send thread func, and send thread func will take in an LP void. This is just a void pointer, pretty much. LP param. So yeah, this is the function signature. And I'll leave that as is for now, because we can write that later. But now, when we're getting ready to do the main loop, to set up the thread, we're going to first have to create another dword for the thread ID. And then we're going to create the thread. And this create thread, this function create thread, will return something called a handle, which will allow us to close the thread when we don't want it anymore. So we're going to say handle in all caps, send thread is equal to the function create thread, and in this function here we're going to pass in null for the attributes, 0 for the stack size. Then now the LP start address is actually just the callback to the function, and that function is going to be send thread function, the signature that we have above. Then the parameter, we're going to pass in the client socket as a parameter. Then for the creation flags is 0, and then for the ID, we want to send in a reference to the thread ID that we have above, so the dword. Alright, so once again, we are calling create thread using on send thread func, passing client as a parameter, and then storing the ID of the thread, and it returns a handle. Now we can do some checking here. So if send thread, then we will print out send thread started with thread ID, and then we'll just print out the ID. And then else print send thread failed with error get last error. So this is a more general error function for Windows, the Windows SDK. So we're going to be doing the receive loop in this main function here. Just the reason why is because we can always pass in a callback to call once we get a message, but the mechanisms are always going to be the same. So we don't want to allow people to customize how we receive messages, but we want to allow people to customize how we send messages, or which messages to send. So we're going to do a do while loop here. So we have started the thread. And then we're going to start the receive loop. So we're going to say do, it's going to be a do while loop. And the condition here will be res is greater than 0. So anytime we receive something and we receive a positive amount of bytes, then we have received a valid message, otherwise the connection has been closed. However, we also want to, now you're going to see that this won't work really. Because, for now we'll leave it like this, but we will add another parameter to determine when we want this loop to pass. So in here we're going to say res is equal to the receive function, so we're taking the receive function, and we're going to pass in the socket to receive on, which is the client. The buffer to write to will be receive buffer, which we need to create. So we're going to have a character array of size bufflen, the macro. So we receive from the client, or we receive onto the client to the buffer receive buffer of length bufflen, and 0 for the flags. Then we want to cut the message off at the terminator, so receive buffer at res is equal to \0, and then if I result is greater than 0, then we want to print out what we received. Or sorry, if the result is greater than 0, then we received a positive amount of bytes. So we're going to print out printf received, we'll print out the number of bytes and then the string. Alright, then else if not res, so res is equal to 0, then the connection has been closed. So printf connection closed, and then break out of the loop, and then else printf receive failed, and then print out the error code from WSA get last error. And then we honestly don't need that break statement because this condition here will not pass. Alright. Now, so we have the receive loop, or yeah, this is just the receive loop. And now once we have finished receiving, so this condition does not pass anymore, therefore either the connection has been closed or the receive function has failed. In either case, we want to shut down the connection. Now before that, we need to stop the thread. We need to forcefully close the thread. So connection is closed, or connection finished, terminate send thread. And we can simply just do this by saying close handle with a send thread. And for close handle, it takes in the send thread handle. So we're the handle that was associated with the send thread, we want to close that handle now, so because we don't want to handle the thread anymore. And then we can also just check to see if this was closed properly. So if, and then if this returns a value, a non-zero value, then it was closed properly. So we'll just print out send thread closed successfully. Alright, so that's the main part. Now, we're going to shut everything down. Now for cleanup, it's going to be easier because we only need to shut down the connection. We only need to shut down one connection. We don't need to shut down all connections. So we're going to do cleanup. It's going to be res is equal to shut down the client socket on both channels. So SD in both. Then if res is equal to socket error, then we're just going to say printf shutdown failed, print out the error as WSA gets last error, and then we're going to close the client socket, clean up WSA, and then return 1. And otherwise, we're simply just going to close the socket, or client, and then do WSA cleanup, and then we can return 0 after that. So that's why we had to do this before or inside the if statement, because we wanted to return 1. Alright, so yeah, this is pretty much the same here, except we are only shutting down one connection rather than looping through an array and shutting down all the connections. Alright, so now before we can run anything, we still have to write the send function. So we have the signature up top. I'm going to copy the signature, and I'm going to go all the way down. Now for the send thread function, we first have to get the client associated with it. Now it's not a global variable because we're passing it as a parameter through this void pointer here. So we have to kind of cast this void pointer into a regular socket. So we're going to say socket client, socket's all in caps because it's the type, and this is going to be equal to the dereference of the socket pointer conversion of LP param. So the LP param that we take in, this is a void pointer. We're converting it into a socket pointer, which is what it naturally is when we pass it in here as a reference to client. And then we dereference it right here so that we can just handle it as a value. Now we're going to have a few more values. We're going to have a character array for the send buffer of length bufflen, then integer send bufflen, and then results as well. Alright, now for our looper is going to have an infinite loop, so while 1, we're going to get a value. So scanf from the console, and just do %s for a string, and send it into, or read it into sendBuff. Then we're going to say sendBufflen is equal to the string length of sendBuffer, and then we're going to send the buffer to the server. So res is equal to send from the client socket. We're going to send the buffer, so send buff. The number of bytes to send is send bufflen, or the string length, and then the flags are 0. Now we want to have a few checks here afterwards, so if res does not equal send bufflen, then break, because we send failed. So I can actually just print out send failed. Now else, if not memory compare, send buff. So we're just going to pretty much do the same stuff as we did up here. So there's going to be a quit command, but then we'll also have a leave command. So the /leave command will just exit the client from the server, but the quit command will quit the server. So we're going to take else if send buff, compare it to /leave, and compare 6 characters. If that is not a value, then break. And then after everything, we need to return 0. So outside of the loop, we need to return 0 since it's a successful thread. Alright, so we have our client, and let's try just running it. Connect failed. Server's not open. Good, that's what we expected. So let's actually go ahead let's go ahead. Is this source here? Source, yeah. Challenges, there we go. I was messing up where I was. Alright, so let's get the server. Let's run it. Alright, hello world accepting on 127.0.0.1. That port. Run it. So, hello world, send thread started with thread ID 11620, and we received the welcome message from the server. Server side, we can see client connected at 127.0.0.1 at this port here, and we add it to the list. Let's send a message. Hello server. Did it not get it? Oh, there we go, yeah. Oh, I made a mistake. This should be get line, because it was sending it as 2 messages since there was a space. Alright, that's fine. Doesn't really matter. So yeah, we send the message and we get the message back since it echoes. Alright, so what's up? Receive the message back. Now let's try doing our leave command. So /leave. Now this is not going to do anything because we'll see this is a problem. And I'll explain it in a second, but let's just try to /quit. What's happening? No. Alright, I don't know. Run. /quit. It closes everything out. So we get the client disconnected because that was just a mess up, and then we connected back, sent /quit, shut the server down, sent goodnight, and we also received the goodnight message before closing the connection. And we close the connection, or the send thread. Now, what was the problem with doing the leave thread? So if we do /leave, oh, well, we closed the server, so we need to rerun it. Yeah. So let's run it. Get the welcome. So we should, when we do /leave, we should be leaving, right? Because in our send thread, we say break. So we break out of the loop, end the thread, we return 0, we end the thread, good, good, good. That should be enough. However, we're still in this loop. We're still in the receive loop. So here comes the concept of sharing variables between multiple threads. And you could do that with a global variable. However, writing access could get tricky. So we're going to use something called atomic variables, which is a more secure way of sharing variables between threads. More secure as in the reading and writing is guaranteed to give the same result. So as soon as we write a stop, or as soon as we write stop to an atomic variable, then it is guaranteed to stop. Whereas if it's not atomic, the writing could make a copy, or it could get a little weird. So what we're going to do is we're going to create, or we're going to include the atomic header. I don't know too much about atomic variables, so I will I'll put a link at some point about it, but the header will be std atomic. And it's not recognizing it for some reason, but I'm almost 100% sure that it's included in the SDK. Like if I were to run it, build it, yeah. So there's no errors. God, I say errors really weird. But there's no errors because this include file I'm pretty sure is in GCC, but it doesn't find it. So we're going to have an atomic global variable. The way we're going to do the atomic variable is, so we'll have global running variable. So it's going to be a Boolean, but we'll just use a character. So underscore atomic with a capital A. So that's just the keyword to say this is an atomic variable. Character running is equal to 0. So it's not running, it's false currently. Now in the main loop, or in the main function, we first want to, we can also just print out connected to so we're going to set as running. So we'll print out the message, and then we will also say that running is equal to not 0 or true. So now we're going to have two parameters for our loop here. For the do while loop. So the do while will be do while res is greater than 0, but we also have to have running in there. So running and res is greater than 0. So this loop can only happen when running is true and the result is a positive value. So now what we're going to do is we're also going to set running to false when certain things close. So running is equal to 0 when the connection closes, and then also when the receive fails, we'll say running is equal to 0. And then after the loop, running, we'll just set running to 0 just by default. Now in the thread, it's going to be the same thing, except if we say while one and running, this will also always just be the result of just while running. That's just Boolean logic right there. So while running is true. Now this, we want to break out of this, or we want to set a global break when we send the leave command. So when we see that the send buffer is the same as leave, we want to set running to 0, because we already know how to break out of this loop just by using the break command. However, when running is 0, that will also break out of this loop here, so we won't be receiving anything. So we will then close the thread and then shut down the connection, which will then tell the server, all right, this client is gone, no more connections, see you later. Or no more communications, see you next time. And once again, we're using atomic variable for more secure and more guaranteed correctness. So let's try this now. Let's run the server, accepting. Let's run the client. So we will run the client. Alright, so we see successfully connected. I can zoom in actually, and you guys can actually see. Yeah, alright, that's my mistake. I wasn't showing you guys perfectly. So I'll leave that there. Leave that up top actually. Alright, here we go. So we get the welcome message, welcome to the server. Now let's do a hello, receive, echo the message, / leave. See, everything closes. We receive the leave function back because it echoes it back to us as normal. Because the receive function is still active. And that's another thing. We won't get to this condition until receive returns something. So even if we have closed the connection, we still want to get something back. But we're going to have to break out of that at some point. Well, we can also, as another check, we can also just say, before we send, we can say, if not running, then just break. So if we read a character, but we're not running anymore, then don't send it, because it'll just give us an error. Oops, no. You don't want to see that. So yeah, that is the leave. So let's try a few things now. Let's do a few. Let's do a run. So welcome to the server. Start, welcome to the server. Welcome to the server. Welcome to the server. Welcome to the server. And then also I can showcase the new overflow here. So if it's full, we'll receive a message, sorry, the server is full, and we'll close out the connection. Good shit there. But let's go here. So we'll do a hello server. I don't know what that's about. So yeah, we send and receive messages. Now let's try leaving. So we leave, send thread close successfully. All good on that front. All good here. Now what you notice is if I send quit to the server, it will quit the server. We receive good night, connection closed, send thread closed successfully. This is on this client, so we can close out of that one. We can also close out of this one since we left. And here, it closed out of the loop because as soon as we got the quit message, so the connection was closed. So once we ended this loop here, the receive loop, since connection has been closed, we close the thread. So we don't give a fuck if we're currently waiting for a scanf. It just closed the thread, and this is secure, by the way. This won't cause any leaks or anything like that. This is secure. So yeah, it closes out of all of the. We receive the message still. We receive a good night message, but then just close the connection. Get out of there, and get out of there. All right. So yeah, that is clients on Winsock. Yeah, I'll put more stuff about atomic variables and links down below. But yeah, that's all I have for you guys today. Hope you guys, I might be doing another thing on Winsock at some point, but maybe not. I do want to do some more OpenGL stuff. I do need to do more OpenGL stuff. But anyway, I hope you guys enjoyed. I will see you guys in the next video, which, once again, I have no clue what it's going to be on. So yeah, I hope you guys enjoyed, and catch you guys on the... I'll catch you guys next time. Have a good one.